Alright, so in this video, I'm going to be explaining the concept of moles, as well as molar mass and mass, as well as how to convert between all three. And this is really important because it's the foundation of lots of chemistry problems. So, first of all, what is a mole? A mole is simply when you have this number of things. It's 6.02 times 10 to the 23, which is a really big number. Okay, and that might sound confusing. So an easy way to think about it is it's kind of like a dozen. So let's say you have a dozen eggs. It means you have 12 eggs, right? If you have 2 dozen, it just means you do 12 times 2, and you have 24 eggs. Okay? So when we use mole, it's to say that we have this really big number of things. Okay? And then so from that, we can move on to something called the molar mass, which is how much 1 mole of something will weigh. Okay? And the reason that this is important is because in chemistry, all the molecules, all the elements are going to have different molar masses because they're made up of different sized things, okay? So maybe like a simpler way to think about it is, let's say you have a dozen eggs and then you have a dozen donuts. They're two different things. So a dozen of each of them is not going to weigh the same. They're going to have different dozen weights, or in this case, since we're looking at moles, they're going to have different molar masses, okay? So the easiest way that I remember this equation is just think of what the definition is. So the molar mass is the mass divided by the number of moles. So, and this makes sense, right? Let's say if we have 100 grams of something, and then we're told it's 10 moles. That means each mole must be 100 divided by 10. Each mole will weigh 10 grams, okay? So that's how I remember that equation. And then from that, we can rearrange to get any of the other three, or to get either mass or the number of moles, okay? So for example, we can do mass. We could do mass is equal to the molar mass multiplied by the number of moles, which also should make sense, right? The number of moles is how much 1 mole will weigh, and if we multiply by the number of moles, we get the total mass, okay? And we could also find the number of moles by dividing the mass. So we multiply both sides by number of moles, and then we divide both sides by the molar mass. So we divide the mass by the molar mass, and we get number of moles. So hopefully that should make sense, and if it doesn't, just try to play around with it and try to conceptualize what it means. And let's go through a simple example. How many grams of H2O are produced when 64 grams of oxygen react with excess hydrogen? So first of all, we can write the equation for this, and it's going to be so H2 produces 64 grams of oxygen, so it's O2 plus H2 is going to make H2O, and then we have to balance it. So since we have we have O2 and we have H2, so then we have 2 oxygen. You have to have this 2, and this has to be 2 as well. So how many grams of H2 are produced when 64 grams of oxygen react with excess hydrogen? So what we have to do is we have to convert the 64 grams to moles. Sorry, 62 grams of oxygen, of O2. And why do we do this? So then when we convert to moles, then we can easily convert to moles of the product, right? And then when we convert to the moles of the product, we can easily go back using the molar mass of this to go back to the mass. So 64 grams of O2, what I like to do is set it up like this, where you have the same units as right here. So we have grams of O2, and we want it to cancel out so that we get moles of O2, and then we use the molar mass of O2. Well, oxygen is by itself is 16 grams, so 2 of them is going to be 32 grams of O2. So this cancels out, right? If you solve this really quickly, it'll just be 2. So we have 2 moles of O2. And then how many moles of H2O will that make? Well, you can again cancel it out. 1 mole of O2. This will cancel out with this. 1 mole of O2 will make 2 moles of H2O. And then 1 mole H2O will be 18 grams of H2O. Right, this is continuing from here. So overall, we have 64 divided by 32, which is equal to 2, multiplied by 2, which is 64. Oh no, sorry. We have 64 divided by 32, which is 2, times 2, which is 4, and then times 18, which is going to be 72 grams of H2O. Okay, thank you for watching.